It's 11. Okay. Okay, yeah, good morning. Has anyone joined? Has anyone joined us? It's 11. We're about to get started now. We'll continue from where we stopped. Okay. So we stopped at number 9, the other day. We stopped at number 9 the other day. So are we set? Are we good to go today? Are you in the mood to learn? Or the holiday is still in your bodies? Come on, let's holiday be off. We have a lot to do, okay? So hope you can hear me. Are they having problem with their network?
No.
I just go ahead.
Sure you don't do it, say you don't.
Okay. Yeah, good morning. I think we're starting late again today because most of us didn't join on time. So the last time I stopped at number 9. So I continue from number 10. Now I'll always read the questions so you don't have to worry yourself. I'll read the questions and the options for you. I'll read the questions and options for you. All right, number 10. When cathode rays are deflected onto the electrode of an electrometer, the instrument becomes A. Negatively charged, B. Positively charged, C. Neutral, D. Bipolar. The said cathode rays are negatively charged. Your option there is A. Negatively charged. Number 11. When large hydrocarbon molecules are heated, at high temperature in the presence of a catalyst to give smaller molecule, the process is known as, the question again, when large hydrocarbon molecules are heated at high temperature in the presence of a catalyst to give smaller molecule, the process is known as A. Disintegration, B. Polymerization, C. Cracking, and D. Degradation. The answer is C. Cracking. Cracking is a process whereby larger hydrocarbons are broken down into smaller hydrocarbons. So your answer there is C. Cracking. Number 12. If concentrated sulfuric acid is added to sugar and warmed gently, the sugar changes from white to brown. And finally to a black mass of carbon. In this reaction, concentrated sulfuric acid is acting as A. Drying agent, B. Oxidizing agent, C. Dehydrating agent, and D. A reducing agent. Now you can see they said concentrated sulfuric acid is added to sugar and warmed gently. The sugar changes from white to brown. Then finally, a black mass of carbon. Definitely, the water there have been what? Dried up. So sulfuric acid here is acting as a dehydrating agent. So the option there is C. Dehydrating agent. When the water is what? Is not there. That's dehydrated. The water has been what? Has been used up. Number 13. Smoke consists of okay, please, can I know the people that are here, please, before we go on with number 13? Can I know those that are here, please? Can you identify? You can just type in your names. Let me see those available at the moment. And can you hear me also? Before we proceed, can you hear me? Let's see those of us available, please, before we proceed. So I won't just be too fast and at the end, my students are not here getting anything. So please indicate if you are here, please indicate. Let's know those that are online, that are following me, please. Indicate. If you're hearing me and you're online, please indicate before we take number 13. Indicate, please. Please indicate. If you are here with me, please indicate, please, so that we can proceed. Okay. Now let's proceed. Number 13. Okay, Divine. Ukoidem is here. Who also do we have here? We have Ukoidem. All right, so let's take number 13. Let's take number 13 together. 13. Smoke consists of A. Smoke consists of A. Solid particles dispersed in liquid. B. Solid or liquid particles dispersed in gas. C. Gas or liquid particles dispersed in liquid. D. Liquid particles dispersed in liquid. Smoke consists of, the option is B, solid or liquid particles dispersed in gas. Now we'll go to number 14. Number 14. In the electrolysis of dilute sulfuric acid using platinum electrodes, the products obtained at the anode and cathode are, now here, in the electrolysis of sulfuric acid, okay, using platinum, here is it, H2SO4 and H2O. We have the cations and the anions. Okay, now for the cations, this gives us 2H plus, and this gives us what? H plus. Why this gives us SO4, 2 minus, and what? OH minus. Now, the cathode here, the cathode is the hydrogen. The hydrogen is the cathode, and the anode is oxygen. So our option here is C. Number 14, the option is C, oxygen and hydrogen. Are we together? Please let me know if you're not following me, please. Let me know if you're not following me. All right, number 15. 15. There is an equation of reaction 15. P gas plus Q gas to give us is a reversible reaction 3Rs plus S gas. Change in heat is negative. Which of the following will increase the yield of R? Which of the following will increase the yield of R? A. Using a larger closed vessel. B. Increasing the temperature. C. Removing some X. Removing some X. And D. We have adding a positive catalyst. Your answer to number 15 is C. Removing some X. C is the option to number 15. Please, I will advise you always note some of these questions because they always repeat their questions. The syllabus have not changed. The questions are being repeated. So always note some of these answers and questions. Number 16. Number 16. The mass of silver. The mass of silver deposited when a current of 10 ampere is passed through a solution of silver salt for 4,830 seconds is, now don't forget silver. Silver is a univalent ion. So using the formula, 1 mole of Ag plus equals to the relative molecular mass, 108 grams of Ag equals to Faraday's constant, 96500 coulomb. Now we'll go back to the question. What was given? Okay, they said we should find the mass. What? Deposited. Okay, Q equals to IT. Our Q here, the current here was given as 10, and our seconds was given as 4,830. Now the first thing you do is to say 10 times 4830. 10 times 4830. 10 times 4830. 10 times 4830. Okay, now we have 48300 at our Q column as our Q. Now, but we're asked to find the mass. So using this formula, 1 mole of Ag plus equals to 108 grams of Ag equals to 96500 coulomb. Now, putting this into this, that becomes 108 grams of Ag, that's silver, equals to 96500 coulomb. Then 48300 coulomb will give us how many grams? X. You cross multiply. This becomes 108 times 48300 divide 96500. This cancels this. So we have 108. So we have 108 times 483 divide 965. Our answer here is 54.06. Now is gram of Ag. Now what is the option? All right, Chineye, let's take the question again. Since you're lost, follow up. We are doing 2017, please. And at the moment, we are solving number 16. 2017, number 16. Go to your number 16. We are doing number 16. All right, I will take the number 16 again. We are solving number 16. Here, we are asked to find the mass of silver deposited when a current of 10 ampere. When current of 10 ampere, 2017, number 16. I'm taking the question now. The mass of silver deposited when a current of 10 ampere is passed through a solution of silver salt for 4,830 seconds is, now using the formula Q equals to what? IT. Our I, the current was 10, and the time was given as 4830 seconds. They've converted it already. When you times this, you have 48300 coulomb. Now, using the formula, 1 mole of silver to give us the relative molecular mass of silver, 108 grams of silver equals to Faraday's constant. I'm solving Jamb past question 2017, please. I'm solving Jamb past question 2017. Open to your Jamb past question series. I'm solving Jamb past question 2017, number 16. So open to your past question, check number 17. Number 16, sorry, not number 17, number 16, Jamb. Number 16. All right. Now, Q equals to IT. I is the current, 10 times the time. That gives us 48300 coulomb. Now, using the formula, 1 mole of Ag plus equals to relative molecular mass of Ag equals to Faraday's constant. Okay? Now, 108 grams of Ag would give us 96500 coulomb. Then this that we solved, this 48300 coulomb will give us how many grams? X. Cross multiply. You cross multiply. This becomes 108 times 48300 divide 96500. At the end, we have 54.06 gram of Ag. The option to that number 16 is B. B is the correct option. B. B is the correct option to that. All right, number 17. Number 17. There's an equation of reaction given: CO, gas, plus H2O, gas. That gives us CO2 gas plus H2 gas. From the reaction above, calculate the standard heat change if the standard enthalpies of formation of CO2, H2O, and CO2 gas in kg mole minus 1 are minus 394, minus 242, and minus 110 respectively. Now, here, don't forget the formation. Change in heat equals to what? Change in product minus change in what? Reactant. Abi? Now, for your product, our product here is the CO2. This CO2 is your product. And what is the value for CO2? It is minus 394. That is the value for your product. And your reactants here, your reactants are your CO and H2O. Now for your CO, we have values. The values for CO is minus 242, and that of H2O is minus 110. So what do? Minus 242 plus minus 110. We'll add them together. We'll add. Now this becomes 242 plus 110. This gives us minus 352 minus 394. Now minus times minus, it turns to plus. So minus 394 plus 352. Now 394 minus 352. So our answer from here is minus 42. So the correct answer, the correct option there for number 17 is B. B is the correct option. B is the correct option. B is the correct option to number 17. B is the correct option to number 17. Now number 18. Please, are we following, please? Are we following? All right, number 18. Number 18. Okay, Divine. Divine, I'm doing 2017. I'm doing 2017 Jamb. We just finished number 17. If you have your Jamb series, who needs? I just finished 2017. I'm on 2017. Sorry, I just finished number 17. So I'm going straight to number 18. Number 18. I'm going to number 18. Please, are we together? I'm going to number 18 now. Should I proceed? Let me know if I should proceed, please. Let me know if I should proceed. Please indicate. Because this one's, you guys are saying you don't know what I'm solving or you don't understand. If you missed the last class, we were doing 2017 and I stopped at number 9, the first class. So we continued from that same 2017. At the moment, I want to take number 18. I want to take number 18. All right, number 18. Number 18. If the electron configuration of an element is, if the electron configuration of an element is 1s2, 2s2, and 2p5, how many unpaired electrons are there? Now, when we talk about unpaired electrons, the first thing that should come to your mind is Hund's rule. Hund's rule. Hund's rule states that electron will occupy orbital singly first before pairing takes place in a degenerate orbital. Now, you can see we have the s orbital. 1s, 2s, 2p. Okay, 1s is 2, 2s is 2, while your 2p, they said 5. So, how many unpaired electrons do you think we'll have from here now? We have just one unpaired electron. So your answer to number 18 is C. Number 18 is C. We have one unpaired electron. I've showed you how we got it. We have one unpaired electron. There is one unpaired electron. All right, number 19. Number 19. Number 19. Number 19. Which of the following gases can best be used for demonstrating the fountain experiment? Which of the following gases can best be used for demonstrating the fountain experiment? One. Well, first, before we talk about fountain experiment, you should know that nitrogen is mostly used in what? Fountain experiment. So, mind, okay? Number 1, Roman numeral, nitrogen. 2, ammonia. 3, nitrogen 1 oxide. 4, hydrogen chloride. Now, your correct answer there should be 1 and 3, nitrogen and nitrogen 1 oxide. So, the answer there should be B. Number 19 is B. 19, B. Nitrogen and nitrogen 1 oxide. Nitrogen and nitrogen 1 oxide. Number 20. Number 20. The colored nature of transition metal ions are associated with their partially filled A, F orbital, B, S orbital, C, p orbital, and D, d orbital. Partially filled d orbital. Your answer is D, number 20. Answer to number 20, D. Number 21. 21. Which of the following separation process is most likely to yield high quality ethanol, that is greater or lesser than 95% from palm wine? A, frac without a dehydrant. B, simple distillation with a dehydrant. C, fractional distillation with a dehydrant. And D, column chromatography. Your answer there is B, simple distillation with a dehydrant. Number 22. The product formed on hydrolysis. The product formed on hydrolysis of the product formed on hydrolysis of the product formed from hydrolysis of CH3, C double bond O, OCH2, CH2, CH3 in acid HCl is. Now, what is hydrolysis to get started with? Hydrolysis can be defined as a chemical reaction of a due to the reaction of water. Due to the reaction of water. So, when water reacts with this equation, hydrolysis occurs. Now, you can see the options. Option A, CH3, C double bond O, COH. If you have the paper, please look at it. Look at your options. Now, from your options, the correct answer is C. Your correct answer to number 22 is C. Now, I'll take number 23. Sorry, I'm trying to meet up with time. Number 23. In the reaction, here is the equation of reaction. 3CuO plus 2NH3 plus H3 gives you 3Cu plus 3H2O plus N2. Now, how many electrons are transferred for each mole of copper? Don't forget that copper is a divalent ion. So, 1 mole of Cu2 plus would give us 2 times 6.02 1 mole of it will give us 6.02 times 10 to the power 23 ions. Then, since it's a divalent ion, okay, so 2 mole of Cu2 plus will give us, you cross multiply, that will give us what? 12.04 times 10 to the power 23. The closest to it is option C, 1.2 times 10 to the power 24. The answer there is C. Let's take C. C is our closest bet. Number 24. Number 24. Number 24. Number 24. All right, number 24. The electronic configuration. The electronic configuration of an element is 1s2, 2s2, 2p6, 3s2, p3. How many unpaired electrons are there in the element? How many unpaired electrons are there in the element? Now, I told you how to find paired and unpaired electrons, right? I taught you this. So, the first thing we do is we write one S, 2S, 2P. This is your 3S and your 3P, 3P. Don't forget Hund's rule. Pairing will take place first. Electron will occupy orbital singly before pairing takes place first. Sorry. Okay. Now you can see we have 3 unpaired electrons. So our answer to number 24 is C. Number 24 is C. 3 unpaired electron. C is your answer to number 24. Number 25. Number 25. 8.0 gram of an element X reacted with an excess of copper 2 tetraoxosulfate 6 solution to deposit 21.3 gram of copper. The correct equation for the reaction is now copper X. This is X plus copper 6, that is CuSO4. When these two react, you have Cu, which is a gas, plus XSO4. Your answer to that is A. Number 25. The answer to number 25 is A. A. Okay. Now, I think we are going to stop at number 25 for today. By God's grace, I heard school will be resuming. I heard school will be resuming soonest. So when school resume, we'll continue from number 26 of 17. Thank you for those of us that were able to turn in. Thank you so much for your time and everything. And I promise that we will try and complete this series. We will try at least we shall get 20 before you write your Jamb exams. Thank you so much. And if you miss this class, you can actually still watch the video. Okay, go online then watch the video. It's there. I think so much. Do enjoy your weekend. See you soon. Bye. The thing might not be turning upside down because nobody complained.